Good. Enjoying the sunshine. All right, let me start by sharing my screen. Today we're going to look at a few other types of equations. This chapter 1 deals with solving equations and inequalities. We started with those first degree linear equations. Then we introduced word problems, and then we introduced the concept of complex numbers. And then last two classes, we spent solving quadratic equations, looking at different ways of solving those second degree equations. And we realized that that's what we really need those complex numbers for, to be able to solve any second degree equation. Homework 1.4, which is the complex numbers, is to be done by the end of the day today. 1.5 is the assignment on quadratics. But if you remember correctly, I think last class I bribed you with extra credit if you get it done by Friday. 1.6, the other equations that we're looking at today won't be due until end of next week. But over the weekend, there will be a quiz on those operations on complex numbers, specifically multiplying and dividing complex numbers, and rewriting negative radicals in terms of I.
This Friday or next Friday?
This Friday. And also solving quadratic equations. And there will be 4 quadratic equations, one by factoring, one by the square root property, one by completing the square, and one using the quadratic formula. I need you to, again, to show all your work and use the correct method, because some of those questions can take a little bit longer. This quiz, you're going to have more time. I think I allowed like up to 45 minutes for this quiz. But that's another reason why I want to try to encourage you to do that quadratic homework, that 1.5 by Friday, so that we can clear up problems that might exist before you start thinking about taking that quiz over the weekend. Again, saying the quiz is on Friday means that it'll be available after class on Friday, and it needs to be completed by the end of the day Sunday. Before we get started looking at those other equations, I know, again, we did go through a lot with our quadratics, factoring, square root property, completing the square, and quadratic formula. Did anybody have questions on any of those?
I do.
Or on any homework? Okay, give me an assignment, give me a question number.
Assignment 1.4, question number 14.
Okay, assignment 1.4, question number 14. And those of you who ask questions at the beginning of class, thank you. Am I correct in assuming for everybody that going over homework problems is helpful to you all? So I know usually in an on-campus class, I do spend a bit of time at the beginning of each class going over homework. So I appreciate when you guys ask. So what we've got here is -20 plus the square root of -75 over 40. And they want it in A plus BI form. Right now, I don't see an I, but I do see that square root of -75. We want to simplify that radical. Hopefully everybody recognizes 75 as 25 times 3. And because it's negative, we're going to factor out that -1. The square root of 25 is 5. But the square root of 3 is the square root of 3. And the square root of -1 is I. To that point, are you okay? So we've got -20 plus 5 radical 3 I, and it's all over 40. And so right now that's one single fraction, and we wanted to split it up so that we have a distinct real part and a distinct imaginary part. And I think we had said when we were looking at polynomials, and again, complex numbers to some extent behave a little bit like polynomials. I, in some ways, behaves like a variable, but again, we never leave an exponent on it. So I've got two things over the 40. I'm going to put them each separately over the 40. They're both being divided by 40. And I'm going to just put the numeric coefficient over 40, and I'm going to take that I and write it off to the side. But that can still be simplified. 20 over 40 reduces to a half. And 5 over 40 reduces to an eighth. So that'll give me radical 3 over 8 times I. And so this is what you want to type in as your final answer. It's an A plus BI form. We've got it separated into two fractions, not one. The first one is real. The second one is the imaginary part. And again, we want to take the I out of the numerator of that fraction and pull it over as, so that the fraction is the coefficient on I. Better?
Yeah, but I don't know. I wish we would have used the numbers that I used so I could really see where I went wrong.
Do you want to read to me the question that you have in front of you then?
Negative 20 plus the square root of 50.
Negative 20, go ahead, plus the square root of 50, negative 50?
Yeah, negative 50 over 60.
Okay, so tell me what you did with the square root of negative 50.
I turned it into the square root of 25 times 2 times negative 1, making it negative 20 plus 5 square root of 2i.
Beautiful. Negative 20 plus 5 square root of 2i over 60. Beautiful. Then what did you do?
And I know I messed up here because I combined 20 and the 5.
We can't because they're not like.
So now I would separate them, put negative 20 over 60,
Mm-hmm.
and then 5 square root 2i over 60.
5 square root of 2 over 60, and pull that I out to the side.
Oh, okay.
Now, can you reduce those fractions?
Yep. You could divide by 20 on the first one.
That's negative 1/3. And over here, these are both divisible by 5.
Yep.
So that gives
So
me
it'd be the
2 over 12i.
you keep the addition. Yep. Okay.
Better?
And that's your final answer?
I think so.
Yep, that's better. I definitely had it wrong.
Playing the millionaire or something. Is that your final answer?
Yep.
Does anybody else want to look at any other homeworks, any other homework questions? Either the complex number assignment, 1.4, or the quadratic assignment, 1.5.
Yeah,
Can you do 16 from this 1.4?
If it lets me. There we go, we got it. So what this is sort of fun. We've got 4 minus I squared minus 7 minus I squared. Now I want you to think way back to January when we started the semester. And do you remember we started the semester saying there's some basic rules that are always going to hold true. And one of the most basic was our order of operations. That still holds. Order of operations start inside the parentheses, but I can't combine those because one part's real, one part's imaginary. After the parentheses, the next thing we do is exponents. And so let's clear up these exponents. 4 minus I squared. Well, remember, in order to square something that looks binomial, we've got to take it and we've got to multiply it by itself. So far, so good, Rizwana?
Yeah.
And now when you multiply like that, do you distribute, do you FOIL, or do you box?
I distributed.
So I'm going to take 4 times 4 minus I times 4 minus I, like that's how you do it, hon?
No, I just kind of like multiplied like 4 times 4, then 4 times negative I. Yeah, kind of like that.
Yeah, okay. So, well, then I'm going to erase that line. And what you get is equivalent to my old school foiling. 4 times 4 is 16. 4 times negative I is negative 4I. Negative I times 4 is negative 4I. Negative times negative is positive. I times I is I squared. So far, so good?
Yeah.
Then what you have to remember is we never leave I with an exponent on it. Since we had defined I as the square root of negative 1, then I squared is just equal to negative 1. So this becomes 16 minus, combining those two, 8I minus 1. So this part is 15 minus 8I. Happy so far?
Yeah.
Minus, now we're going to do, I have this horrible feeling that there's somebody in a waiting room, there we go, that I can't see. There we go. Now we're going to do the same type of work again, but with the 7 minus I. So 7 times 7 is 49. 7 times minus I is minus 7I. Minus I times 7 is minus 7I. Minus I times minus I is plus I squared. That I squared is negative 1. So that gives me 48 minus 14I. I'm sorry, my pen doesn't want to work right now. Everyone, does anybody else have a problem every once in a while with a digital pen not liking your penmanship? But what we have to remember is it's this first one minus that second one. And you remember to subtract complex numbers. We do it like subtracting a polynomial. We think of there being a negative 1 there. And so that becomes 15 minus 8I minus 48. And then minus and minus will become plus 14I. And so that leaves me with negative, is that 33? Plus 6I.
Is that the answer?
I think so. Check your problem though. You might have different numbers in your problem. Places where you can make common careless mistakes, you have to remember that you have to do those exponents first. And then a real common mistake with ones like this is forgetting that I'm subtracting. After I do that multiplication, I have to remember I'm subtracting those answers. Watch your signs. I'm guessing that if you did anything wrong, common careless mistake would be a sign error after this. Be careful. Better?
Yeah, thank you.
You're welcome. And as Rizwana was starting to ask for that question, I did hear somebody else asking about another one.
Yeah, can we do 1.5 question 16?
Sure. So 1.5 is over here. Whoa, stop it. 1.5, question 16. Well, hopefully we can do it, but first the internet has to let us. I rebooted my router this morning to avoid delays, and somehow Spectrum doesn't like me. 16?
Yes.
Determine the constant that should be added to the binomial so that it becomes a perfect square trinomial. Then write in factor the trinomial. Okay, before we do this one, can I do a simpler one just to refresh you on what we're doing?
Sure.
If instead that were x squared minus, do you have a favorite even number?
6.
Minus 6, x. And remember to fill in that blank. What we did was we took that -6, divided it by 2, and squared it. And so that became -3 squared, or 9. And we added a 9, and that factored into x minus 3 squared. Do you remember doing that?
Yeah.
Now I want to add a something before here. When I think of taking that -6 and dividing it by 2, can't I also think of it as taking half of -6? We're taking half of that coefficient, which is why we divide it by 2 and square it. With me so far?
Yep.
But that's not the problem we have in front of us. The problem that we have in front of us isn't quite as pretty. We've got x squared minus 3/4 x, and we've got to decide what has to be added there and then how it would factor. But we're going to do the same thing. We're going to take that first degree coefficient, which is -3/4, and we're going to take half of it. But to take half of it, rather than dividing by 2, I'm going to multiply by a half because it looks easier that way with fractions. Doesn't that give me -3/8 that I have to square, which means that I'm going to add 9/64. 3 squared is 9. 8 squared is 64. And this will become x minus, and the number that I square is the number that would go in there. So it's -3/8 because it was a -3/8. And you see how it's the exact same thing we did with if it were an even number. It's just that if it's not an even number, don't let the problem hear me say this because I don't want to hurt its feelings. But if it's not an even number, it looks a little uglier, but the work is exactly the same. Any better?
Yep. Thank you.
Okay. Do you notice it's one of those things like the dog, the bark is worse than its bite. It's, it looks hideous, but it's no different than what we did otherwise. Okay. Does anybody want to look at any other ones? Okay, I need help here, folks. I'm a patient person, but I'm not that patient. Did I wait long enough for more homework problems? Are we all good?
I guess so.
Okay, great. And again, if you have more questions on those, especially the quadratics, please bring them to class on Friday. And oops, I didn't do what I should have done, which is what I try to do every class, but I don't necessarily always do a good job of it. When you're doing that homework, if you have a question on a problem, never stress. Never spend hours on the same problem. I am only an email away, and I would like to help you if I can. Please do not stress. If you have a question, use it's my internet. Use this question help. You can watch a video, you can look at the textbook, but please don't be hesitant to use that Ask My Instructor. Usually I respond to those emails relatively quickly. If it's something that I find I can't type, because you know how sometimes it's annoying to type math, I will write it out and send that explanation to you as an attachment. If I send you a response and my response doesn't make sense, please go back to me again and tell me that doesn't make sense. Try again. So, okay, because I don't want to ever see anybody lose their enthusiasm to the subject matter because they're stressing too much over something. So please feel free to ask questions. Probably the easiest way is with that Ask My Instructor button. Okay. So where are we going? So far, again, this chapter, we've looked a little bit at graphing. We looked at solving first degree linear equations, including ones with fractions, rational equations. We looked at solving word problems. We looked at complex numbers, and we looked at quadratic equations. This next section, I believe it's section 1.6, is called other equations. And so we're going to look at solving equations besides linear equations, rational equations, and quadratic equations. The first type of other equation, I think we're going to look at two. There's 4 types of equations in this section. I'd like to look at 2 today and 2 on Friday. The first type that we're going to look at are polynomials. So polynomial equations with a degree higher than 2. So we might have 3rd degree, 4th degree, or even higher. Let's look at an example. And as we go through this example, write down what we need to be able to do to solve these. So for my example, I'm going to have a cubic, a 3rd degree equation, 2x cubed plus 3x squared equals 8x plus 12. Can everybody look at that and see that it's higher than 2nd degree? It's got an exponent higher than 2. So, looks a little cumbersome, looks a little overwhelming, but it really isn't. With an equation with an exponent higher than 2, the first thing that we want to do is we want to make one side 0. And when we make one side 0, we want to have the other side in descending order. And so as I look at this equation, you guys have been solving several equations. Which side would you rather make 0? The left or the right?
Right.
Right, yeah, I usually like if my highest degree term is positive, I like leaving it put. So in order to make that right-hand side 0, what would you say we have to do?
Subtract 8x minus 12.
Subtract 8x and 12 from both sides. And is everybody all right if I multitask and do them both at the same time? I'll do the hard side. 8x minus 8x is 0. 12 minus 12 is 0. That side's 0. Woohoo, we did what we wanted. Now on the other side, does everybody notice there are 4 terms here and none of them are like? So I can't combine any. And that leaves me with 2x cubed plus 3x squared minus 8x minus 12 equals 0. And now that we've got one side 0, the reason we did that is because we want to treat these higher degree equations in a manner similar to the first way we solved quadratics. And the first way we solved was by factoring. So what we want to do now is we want to factor what's left completely. Oh, that magic word, factor completely, means there's a chance that we might have to factor more than once. So don't think just because you factored the original problem, you're done. When I see those words factored completely, the first thing I look for is a common term. And as I look at those 4 terms, common factor, pardon me, as I look at those four terms, does anybody see anything common to all four of them?
2.
2 goes into the 8 and the 12, but I don't think it goes into the,
Yeah.
yeah, I like the way you're thinking. I like what you're trying. Because
Just
that's
one.
Yeah, just one, and factoring out one does us no good. Crap. But now, wait a minute, there's four terms. Can anybody remember when we had a polynomial with four terms and we had to factor it? What our first attempt was after a combination?
Split it in half.
Yep, and so when I split it in half, if I just look at the 2x cubed plus 3x squared, do they have anything in common?
X squared or just
X
X?
squared. X squared. X is common and we use the lowest exponent. And when I divide both of those by x squared, I get 2x plus 3. That was so much fun. Let's do that same thing again, but with the back half of the problem. As I look at that minus 8x minus 12, is there anything common to negative 8x and negative 12?
-4.
Beautiful. And when I divide that -4 out, I'm left with 2x plus 3. And woohoo, the magic happened. Is there anybody who's got a big grin on their face? Because this factoring by grouping, splitting it up the middle, is only effective if when I do that, I've got something in common. And does everybody see what I've got in common is the 2x plus 3? That's one of my factors. And then does everybody remember the leftovers of the problem, the x squared minus 4 would be my other factor. But wait a minute. We said factor completely. Can we factor that anymore?
Not that I see.
No, I don't think we can factor 2x plus 3. But how about x squared minus 4? They're both squares, and there's a minus sign in the middle. Doesn't that factor into, let's see, x squared? Well, that's x times x. 4 is 2 times 2. To be a -4, one's a plus and one's a minus. Do you remember the difference of squares factors into the sum and difference? Do you see it now?
Yep.
So now that it's factored completely, and we know that when I multiply those things, the product is 0, can't we use the 0 multiplication property to set each factor equal to 0? And so this was a third degree equation. And since it's a third degree equation, I'm going to have 3 equations to solve here. After I set each factor to 0. And so we'll solve those resulting equations. Oh boy, so how are you guys going to solve 2x plus 3 equals 0? Any ideas?
-3 to the 0.
Minus 3 from both sides, beautiful, gives me 2x equals -3. Are we done yet? What should we still do?
Divide by 2.
Beautiful. And so I get x equals -3/2. I would leave that as a fraction. I wouldn't change it into a decimal unless the direction specifically asks you to. 1 down, 2 to go. To solve x plus 2 equals 0, is it obvious to everybody else? Subtract the 2 and get x equals -2. And to solve x minus 2 equals 0, I'll add the 2. I don't know why I drew that line there. And that gives me x equals +2. And so again, third degree equation, we spoke before about the degree of an equation telling us how many solutions we might have. This was third degree, so we shouldn't be surprised that we have 3 different solutions. And if we were good people, we would check all of them, all the solutions in the original. And so, are you guys all right? We would have to go back and check it in the 2x cubed plus 3x squared equals 8x plus 12. And is everybody comfortable with how to do a check to put each of those values into the variable and make sure the 2 sides are the same? If that's all right, just this once I want to be a cheater and not do the check, because some of the other equations that we're going to look at are a little bit more involved. Any questions on this one?
Do you just plug them each in individually and one
Yeah.
of them's right, or are they all supposed to be right?
You're supposed to plug them each in individually. So I've got 2x cubed, what was the original equation? Plus 3x squared equals 8x plus 12. Let's do one of the 3 checks. Would you rather check the -3/2, the -2, or the 2?
The 2.
So if x equals 2, we're checking does 2 times 2 cubed plus 3 times 2 squared equal 8 times 2 plus 12. Let's see, order of operations, 2 cubed is 8, so this is 2 times 8. 2 squared is 4, so that gives me 16 plus 12, or 28 on this side. On the other side, 8 times 2 is 16 plus 12, which is 28, so it checks. And we need to do that with each of the answers. We have to do the
And they
same.
should all be equal, is what I was wondering. Okay,
Yes, they should all be equal.
sounds good.
If so, my next example looks a little bit different. And again, my next example, there's a common careless mistake that people make at the beginning. We don't want to make that careless mistake because we don't want to lose any solutions. So I'm going to start with 3x to the 4th equals 81x. And again, remember the first thing we want to do is make one side 0. Which side would you folks rather make 0? The left or the right?
All right.
So we'll subtract 81x from both sides. And that gives me 3x to the 4th minus 81x equals 0. And now we're going to factor completely. And again, when I see factor completely, I have a checklist I go through. First thing I say to myself is, so, is there anything in common? And I see 2 things in common. They can both be divided by 3, and they both have an x. The lowest exponent is 1, so my common factor will be 3x. And when I divide 3x to the 4th by 3x, I get x to the third. When I divide negative 81x by 3x, I get minus 27. And so we factored once. But again, if we're factoring completely, we shouldn't be surprised if we need to factor a second time. And so over here, I have a binomial. They're not squares. But does anybody else notice that over here we have an exponent of 3? So I'm going to look and see if that's the difference of cubes. And can anybody remember, if I have the difference of cubes, I think we wrote it as a cubed minus b cubed, that always factored into a minus b, going to keep the same sign. A squared, going to square it. Opposite sign, plus I'm going to multiply them ab, and I'm going to always end with the last one squared. So as I go through and factor this, I don't want to lose my common factor of 3x. That difference of cubes, well, that's x to the third minus 27 is 3 to the third.
I'm
Then,
confused by that difference cubes because there's only one cubed.
no, 27,
Oh, you turn
Is-
it into its
yeah,
what it
is
would be
3 to
cubed.
the third. Yeah. I apologize, I wasn't clear on that. Does everybody recognize that 27 is 3 to the third?
My bad.
No worries. Thank you for asking. And again, what gives me the heads up to look to see is 27 a cube is the fact that that is x to the third. Whenever I see, a binomial and we've got a variable to the third power, I'm kind of in my mind, I'm looking at that other numbers in the problem and saying, is there something I can cube to get there? And so this would be x squared plus the product 3x plus the last one squared 9. And every time we did this, we ended up saying that that last part is usually not factorable. So I'm going to go ahead and take each of these factors and set them to 0. Solving the first one, I'm going to divide by 3 and get x equals 0, one answer. Solving the second one, I'm going to add 3 to both sides. And I get x equals 3. Two answers. This was a fourth degree equation, so I should be expecting up to 4 answers. Now, wait a minute, what am I going to do here? This is a quadratic. And we already said that it does not factor. So I can't solve it by factoring. Oh boy. But hey, wait a minute. Didn't we have a couple other ways of solving them? I don't think we're going to use the square root property because I don't have a quantity all alone squared and just a constant. But I have a couple other choices. Do you guys want to complete the square? Or do you guys want to use that quadratic formula? Does anybody have a preference? Not
Complete
here.
the square.
complete that.
Sure.
I was gonna say that honestly, because this middle term is odd, when I divide it by 2, I'm gonna get fractions. So usually if the middle term is odd, I kind of gravitate towards using the quadratic formula, unless you really like fractions. Are you all right if we use the quadratic formula?
Yeah, okay.
A is 1, B is 3, C is 9. And again, if that middle term, that first degree coefficient is odd, I have a tendency, that's where the ones where if it doesn't factor, I pull out my quadratic formula. And the formula is x equals, oh gosh, can anybody remember it? X equals,
Negative b. Is it then square root?
plus or minus,
The square root of b squared minus 4ac, or is that wrong?
yep, that's right.
Over 2a or something like that.
Yeah, exactly like that.
Oh, I got it.
X equals negative b plus or minus the root of b squared minus 4ac all over 2a. I'm sorry, I promised you guys I'd never sing again, and I just sang. Somehow that helps people, some people remember it.
It does, because I didn't think I would get it.
Yeah, just, the pop goes the weasel goes pretty far with this one. So negative b would be negative 3 plus minus the root of b squared would be 3 squared minus 4 times a is 1, c is 9 over 2 times a is 1. Gives me negative 3 plus minus the square root of, let's see, 9 minus 36 would be negative 27 over 2. Woohoo! We've got one of our most favorite things in the world. We've got something that tells us we're definitely going to have a complex pair of complex solutions. And so I want to scrap paper off to the side. I want to look at that square root of negative 27. It's negative, so I'm going to take out a factor of negative 1. Can anybody think of how I could factor 27 where one of the factors is a square?
9 and 3.
Beautiful. And so the square root of 9 is 3. The square root of 3 is the square root of 3. And the square root of negative 1 is I. So this gives me negative 3 plus or minus 3 radical 3i all over 2, which gives me, let's see, negative 3 over 2 plus 3 radical 3 over 2. We pull that I out. Or the other one would be negative 3 over 2 minus 3 radical 3 over 2i. And by the way, what we did here, whoa, my pen and I are not friends. What we did here, doesn't it look like that first problem somebody asked about from homework 1.3? And so that wasn't just an exercise in simplifying a fraction, but rather an exercise to help us realize, master the work that we need to do when we're using our quadratic formula and we're going to get complex solutions. I made that too small, sorry. How cool is that one? And so that was 4th degree. And we got 4 solutions. Shall we try another? And I guess that was a hypothetical, should we try another? I'm telling you guys, we're getting ready to try another. And I'm gonna be quiet for a minute and give you folks the chance to make one side 0 and factor. I'll give you guys like 2 minutes to do that part. And then once we've got it factored, let's regroup and look at solving the result, setting each factor to 0 and solving the resulting equations together. And this is the part of class where I really miss being in a classroom with you guys, because what I would be doing is walking around the room looking over everybody's shoulders.
Are we gonna do this on our own?
Yep, just the first part, making one side 0 and factoring. Did anybody else get it to factor to 4x squared times x squared minus 3?
Yep.
I don't think it factors further. So now let's go through together and set each factor equal to 0. And look at the type of equations that we have to solve. The one on the left, is it obvious that we're going to want to try to divide both sides by 4? And that gives me x squared equals 0. We've got a square equaling a constant. So let's use that square. I apologize. Let me undo that. Let's, I'm going to rewrite it so that when you look back, you can see where it came from. Let's take the square root of both sides, remembering there's plus or minus on the right. But doesn't that just give me x equals positive 0 is 0, negative 0 is 0? So over here, it's all right if you just write this as x equals 0, but realize it's a double root. We got the answer of 0 twice.
Not that it matters, but why was the plus or minus put in front of the square root of 0?
Will you hold on to that question for just a second? And we'll see why when we deal with the other side.
Okay.
So on the other side, is it obvious we're going to add 3 to both sides? And that gives me x squared equals 3. And remember that square root property. We had said when we go through and we take the square root of both sides, we have to remember that both sides numbers have 2 roots, a positive 1 and a negative 1. And so we get x equals the square root of 3 positive, or x equals the square root of 3 negative square root of 3. Do you remember, like, for example, give me a second. I'm going to backtrack. Do you guys want me to hold off for a minute before I backtrack? In the first example that we did, we got that x squared minus 4 equals 0. And if I go way over to my scrap paper, where we had that x squared minus 4 equals 0, we factored it further. But couldn't we have changed that into x squared equals 4 and used that square root property? But we have to remember that 4 has two roots, a positive or a negative. And so hopefully that puts an exclamation point. Whenever we use that square root property, it's a technicality. Everything has two roots, a positive or a negative. But over here, when we look at the roots of 0, because 0 is neither positive or negative, it kind of, there it looks a little bit ambiguous to do it. But over here, do you see on the other side why we've got to consider both the positive and negative roots? And so does that half of the problem answer your question? Why did I put the plus minus in front of the root? Better or no? It's quiet. Did I get bumped? Can you guys still hear me?
Yeah, I can
Yeah, I
hear
can hear you.
Does that make more sense why we put that positive and negative? Because again, every number usually has two roots, a positive one and a negative one. 0 really is the only exception to that rule. So, okay. So if we have an equation with an exponent higher than 2, we make one side 0, we factor as much as we can. We set each factor equal to 0, and then if we have a second degree equation, we can solve it sometimes by factoring, sometimes by using the square root property, sometimes by completing the square, and sometimes by using their quadratic formula. So that next homework, that 1.6, the first part are going to be equations like this. Did you folks want to try one more on your own? Or go ahead.
What is our final answer? X equals 0 and then the other two of 3?
Yeah, we have 4 answers, but 2 of them are 0. So my solution set would be 0, the square root of 3, and the negative square root of 3. All right?
Yep.
Did you guys want to try another one of these on your own, or do you think you've got it mastered?
I think I got it.
Everybody else okay with them?
I'm good.
All right. Then the next type of equation that we're going to look at are radical equations. When I refer to a radical equation, I'm referring to equations where there's a variable in a radicand. We're going to look at 2 types. The first type is going to be equations with a single radical. Just one square root in it. So an example might be 2 times the square root of 20 minus 8x minus 2x equals 0. How fun does that look? We're going to have to somehow gently massage this, or maybe bully it a little bit and push and shove to try to get that variable out from under the radical. In order to do that, the first thing that we want to do is isolate the radical. Which is a fancy pants way of saying I want to get the square root all alone on one side of the equation. And so, is it obvious that if I'm trying to get the square root alone, the first thing that I'd probably do is get that term alone and add 2x to both sides. So that'll give me 2 times that radical is equal to 2x. And now the radical term is alone, but it's still got this coefficient of 2. So now I'm going to go through and take both sides of that equation and divide by 2. So I'm left with that square root of 20 minus 8x is equal to x. And now that radical with its crazy looking radicand is isolated, it's all alone. Can everybody follow the reasoning to that? Does it make sense so far?
Yeah.
If so, now that we've got the square root alone, and again, we need to get that variable out from underneath the square root. In order to do that, we're going to square both sides of the equation. So I'm going to rewrite what we have. So if there's anybody who's not in class who's looking at the notes, you can see what we've done. We took that equation that we got and we squared both sides. And when I square a square root, remember we just get the radicand. When we square a square root, it's kind of like taking that head off. And so that gives me 20 minus 8x is equal to x squared. I have to tell you guys, I feel so foolish sitting here at my dining room table saying that when we take the radical, it's like taking the hat off, because I'm literally making the motions as if I'm taking the hat off my head because I'm so used to doing this in front of a class of people. But yeah, never mind. So far, so good. Get the radical alone and then square to get rid of the radical. And now that's going to give us an equation to solve. Don't be surprised if that new equation is a quadratic or something like that. So we're going to solve the resulting equation. And again, because I have a variable squared, I'm going to, I guess we could do a couple of things. We could make one side 0 and factor. We could make one side 0 and use the quadratic formula. Or we could get the constant alone and complete the square. But of all of those things, factoring was the first thing that I learned how to do. So I guess that's most within my comfort zone. So I'm going to start there by making one side 0. And seeing if I can factor. And I do believe that this one is factorable. X squared will be x times x, that 20. If I look at it as 2 times 10, with different signs, it'll give me the 8 in the middle. And I think if I make it a -2 and a +10, I get that +8. Now we'll use that zero multiplication property to set each factor equal to 0 and solve again. So get x equals 2. And I get x equals -10. And now with these, the checks are not optional. You must check each in the original. Is that dramatic enough? You've got to do your checks with these. Because these are one of those types of equations where we get extraneous roots. When we square both sides, we're doing the same thing both sides, but we're not real sure what we're multiplying both sides by. And so we've got to do that check. So my original equation was, whoops, 2 times the square root of 20 minus 8x minus 2x equals 0. If I check x equals 2, that gives me 2 times the square root of 20 minus 8 times 2 minus 2 times 2. And my fingers and toes are crossed. I want to know, does that equal 0? It gives me 2 times the square root of 8 times 2 is 16. 20 minus 16 is 4. Minus 4. The square root of 4 is 2. So that gives me 4 minus 4 is 0, and it checks. Yay, happy face. But we're only halfway there. If x equals -10, that gives me 2 times the square root of 20 minus 8 times -10 minus 2 times -10 is supposed to equal 0. So let's see. Negative times negative is positive. 20 plus 80 is 100. Minus times minus is positive. 2 times 10 is 20. The square root of 100 is 10. And 20 plus 20, 20 plus 20 is not 0. And so we reject this solution. And that's one of those extraneous roots. Okie dokie.
So the answer is just 2 then?
Yep. So this is the only answer. And it is not unusual with these equations to get a solution that does not work. And so you always want to check with these. Usually, you know, like with those quadratics, unless you made a careless mistake, our answers should check. But with these, it's not unusual to have answers that don't check. And we have to know that we've got to throw those away. So with these, the checks are super important. All right?
Yep.
Next example. Let's look at x minus the square root of x plus 11 equals 1. Again, I see that square root, and I think I've got to get that square root alone. So let's subtract x from both sides. The negative square root of x plus 11 is equal to negative x plus 1. I've got that negative sign out front. So it'd be more aesthetically pleasing, I think, if we divide both sides by -1. And I get the square root of x plus 11 is equal to x minus 1. Now that the square root is alone, the square root, pardon me, is alone, we want to go through and we want to square both sides. To get that variable out from underneath the radical. On the left, when I square a radical, I just kind of take its head off. I get the radicand. On the right, when I square that, remember, when I square a binomial, I can think of multiplying it by itself, or having completed the square, it might be easy for you to remember. It's the first term squared minus twice the product plus the last term squared. But again, if you don't want to remember that pattern, feel free to multiply that binomial by itself. Now I've got this second degree equation. So to solve this second degree equation, let's start by making one side 0. Which gives me 0 equals x squared minus 3x minus 10. Again, if you want to, you can complete the square, or you can use the quadratic formula. But I think this one's a pretty easy factor. X squared is x times x. 10 is 5 times 2. Because it's a -10, my signs are different. And so if I make it -5 and plus 2, I should get that -3 in the middle when I multiply back out. So now I'm going to set each factor to 0. And I get x equals 5, or x equals -2. But again, with these, that check is super important. The original equation was x minus the square root of x plus 11 equals 1. If I put in x equals 5, that gives me 5 minus the square root of 5 plus 11. We're wondering, does that equal 1? So what is that? That's 5 minus the square root of 16, which is 5 minus 4, which is 1. So it checks. Now let's check that x equals -2. And I get -2 minus the square root of -2 plus 11 is supposed to equal 1. So that's -2 minus the square root of 9. -2 minus 3, or -5, is definitely not 1. And so I'm going to reject the solution, and my only solution is 5. What do you folks think?
Not too bad.
All right. Sadly, we didn't get to one of these equations that have two radicals. If they have two radicals, there's twice the fun, but I can't get one with two radicals done in 2 minutes. So I'm going to